Good afternoon, all of you. Welcome to this lecture of refrigeration and air conditioning. So today, like we have cancelled this project day up to your this Rubicon training goals. So when that training will be over, after that regular timetable will be followed. So today in this lecture, we'll continue our yesterday's quest of finding out the total capacity of a refrigeration system. So we are now going to design one cold room. So cold room, you can consider it as a small replica of a cold storage. Cold storage are like a multi-floor. Cold room, it is of the size of a room, and purpose is same to store perishable fruits and vegetables. Okay. So just quickly, I will take a revision of yesterday's lecture. So we'll first see what are the cooling loads that are acting on that we have to consider while calculating the capacity of a refrigeration system. Okay. So first it was transmission loads. Transmission load means whatever heat is being transferred by conduction and convection inside the cold room, that we have to consider. So in that case, we have to consider heat transfer through walls, roof, and floor. So if this cold room is situated on ground, so in that case, our floor will be ground. If it is situated on another cold room, in that case, that surface in between these two cold room, that will be our floor. Okay. Then second, we have considered the product load. Product load means in that case, I am going to store one of the products. So if it is a fruit, if it is a vegetable, that I am going to put inside that cold room. In that case, I have to consider both its sensible load, that has been heat carried away in the sensible form, plus its respiration rate. आता respiration काय असतं मी सांगितलं, इट इज ऑक्सिडेशन प्रोसेस. त्यामध्ये आपण ऑक्सिजन घेतो, आपल्यातले जे ऑर्गॅनिक सबस्टन्स असतात त्यांचं ऑक्सिडेशन होतं, आणि इन दॅट केस carbon dioxide is generated, so we exhale that carbon dioxide. But as the oxidation process is a exothermic reaction, so it will definitely emit some heat. So that also we have to take into consideration. Third is internal loads. Internal loads means there will be workers which will come inside the cold room. So heat emitted by those workers plus whatever lighting we are providing inside the cold room, that load due to lighting, that also we have to consider. So that will be considered under internal loads. Fourth was the refrigeration equipment load. That means if I'm using a refrigeration system, in that case a fan will be used. So there will be a fan coil unit inside the cold room, which will create the airflow patterns inside the cold room. So that fan will have motor. Okay, so obviously motor will heat up and it will emit some, or it will release some heat into the cold room. प्लस इफ देर इज इव्हॅपोरेटर कॉइल्स, इव्हॅपोरेटर कॉइल आपल्याला माहिती आहे की फ्रोस्टिंग होतं. फ्रोस्टिंग म्हणजे काय, तर त्या कॉइल्सवर बर्फ जमा होतो बिकॉज ऑफ इट्स लो टेम्परेचर ऑफ रेफ्रिजरंट. सो इन दॅट केस आय हॅव टू रिमूव्ह दॅट आइस. दॅट प्रोसेस इज कॉल्ड एज defrosting. So defrosting, it can be achieved with the help of a heater coil. मग त्यामध्ये मग मला त्या हिटर कॉइलचा लोड प्लस त्यामध्ये त्याची इफिशियन्सी किती आहे, दिवसातून किती वेळा मी डिफ्रोस्टिंग केले, ते देखील मला कन्सिडर करावं लागतं. सो दॅट विल बी अंडर रेफ्रिजरेशन इक्विपमेंट लोड. And the last one is infiltration. So infiltration means this unwanted entry of the air inside the cold room. So whenever I open the door of cold room, in that case, the air will be transferred from outside to inside. So that air will carry some sensible load with it. So that also I have to take into consideration. Okay. So in that case, infiltration, I have to consider number of volume changes. Number of volume changes. This means that how many times that total volume of the room is being replaced by the outside air. Okay, so whenever I am opening a door of a cold room, in that case, outside air will replace inside air, and how many times this volume, total volume of air inside the cold room is being replaced, that will become come under number of volume changes. Into its energy, energy means whatever energy is being transmitted with the help of this air into their temperature difference. So temperature difference will be T outside, temperature of outside air, minus temperature of inside air, divided by 3600. So that will be give you the unit in the terms of kilowatt hour per day. So these are the loads which are acting in this case. High loads we have seen: transmission load, product load. Then we have seen internal load. Then we have seen refrigeration system load. And fifth one was infiltration load. So I have to consider all these loads. Then I have to calculate total load acting on the system. Then I have to design a refrigeration system. Okay, so this is a problem we were considering yesterday. So I have example of a cold room, which I'm using for the purpose of storing apples. Okay, so it's a size I have given you here. Okay, so size I have given in front of you, 6 by 5 into 4. So that means 6 by 5, it is the base. Okay, 6 by 5. And that height will be 4 meters. So this is a pretty big cold room. Height is 4 meters, 6 is width, and 5 is the breadth. Okay. Then whatever food I'm using in this case, it is apple. So its specific heat is the 3.65 kilojoule per kg Kelvin. Respiration rate, it is a 1.9 kilojoule per kg per day. Okay. So it is that respiration rate. So I have told you that respiration is an oxidation process. Oxidation is an exothermic reaction. In that case, it will release some energy. Okay. And 3.65 is its specific heat. Okay, then quantity is 4000 kg per day. So daily I am putting in 4000 kg, or we can say 4 tons per day of apple inside it. But see here, if this is your cold room, so I have drawn a diagram here. So I cannot make use of 100% of its capacity. So generally 50% of volume of that room will be utilized to store the room. 20% will be in and out. So 20% will be taken out when the worker will come inside. Then after some time, worker will come and he will put 20% more than the capacity. So that way you have to consider 20% extra. Okay. Then fourth was panels. So for insulation, in this case, I have used puff panel. So nowadays, commercially, they are using this puff panel. So if you have seen these cold storages outside our Pandharpur city, these old cold storages, they in their time in 1985 or 1990, they were constructed. So they were constructed just like our regular buildings. So all the walls were made up of cement walls, bricks and cement, and then they have applied the insulation material from inside. But if you see the new cold storage which is being built on that before Khardi, so on that Pandharpur Sangola road, so that cold storage, it is completely made up of puff panel. So he has not made of concrete and bricks. Whole that cold storage building he has constructed with the help of puff panel. Okay, so that cost of cement and bricks, it is been avoided. So that U value, overall heat transfer coefficient for puff panel, it is given as 0.28 watt per meter square Kelvin. Okay. Now speaking about the temperatures, so outside temperature it is I have taken it as a 30 degrees Celsius. Then inside temperature we'll keep it as 1 degree Celsius. Temperature of floor will be, or the ground will be 10 degrees Celsius. Okay. Then temperature of fruit will be 5 degrees Celsius. So I assume that the fruit or the apple has gone through some pre-cooling process. Its temperature is reduced to 5 degrees Celsius. Then it is kept into the cold room. Okay. Next is lighting. So in this case, I have assumed that there are 3 lamps which are of the capacity 100 watt and which will be working for 4 hours per day. Now it is not that continuous 4 hours they will work. It may be like I have gone inside and I have switched on the lights. So they are on for 15 minutes. Then I have gone for, in another case, this lights will be on for 10 minutes. So collectively they have said that they are on for 4 hours per day. The next is people. So in case of this, I have assumed there are 2 workers and they will come and inside the cold room. So their whole presence inside the cold room, I have assumed it as a 4 hours per day. Then there is a fan, that is a evaporator fan. So one fan I have assumed, which is a 200 watt capacity, which will work for 14 hours per day. So I have told in last lecture, these cold storages, they don't operate for 24 hours per day. So they will operate for 12 to 14 hours per day, and at the night time, or when that sun in the night time, and when this solar load is not there, in that case they will shut down this refrigeration system. So in our case, we assume that this system is working for 14 hours per day. Okay. Seventh load is a defrosting of evaporator. In this case, I will use a heating coil which has a capacity of 1.3 kilowatt. I will use it for 30 minutes once, and within a day I will do the defrosting for 3 times. So 3 times per day. Its efficiency is 30%. So this heating coil is having efficiency of 30%. Then infiltration. So in this case, infiltration is I have assumed in this case it is as 5 वॉल्यूम changes per hour. That means एका दिवसातून जो एअरचा व्हॉल्यूम आहे कोल्ड रूम मधला तो 5 वेळा रिप्लेस होतो बाहेरच्या एअरने. सो इनफिल्ट्रेशन मीन्स वी दॅट जे एअर आत येते जे आपण अवॉइड करू शकत नाही, जसं की दरवाजात काही क्रॅक असतात किंवा दरवाजा खाली फट असते त्यातून जे एअर आत येते जे आपण अवॉइड करू शकत नाही, सो दॅट विल बी कन्सिडर अंडर इनफिल्ट्रेशन. So this was the given problem, and so first step is to calculate the load, then we can decide the refrigeration system. So first load we'll consider it as a transmission load. So that is a heat carried by conduction and convection. Okay. So Q1, that is a transmission load, which is equal to U, which is a overall heat transfer coefficient, into A into delta T into 24 by 1000. So this 24 by 1000 is just to make that unit in kilowatt hour per day. Okay. So here I have drawn that diagram. So suppose this is 6, this is 5, and this is 4. So if I want to calculate the surface area of this, suppose if I take the side walls, okay, so these are the side walls, this is a roof, and then there is a floor. So first, if I take a side area, so this will be, so see here, this will be 6 into 4 into 2. Okay, so 2 into, there are 6 into 4, plus there will be 5 into 4, so that will be again twice. So 5 into 4. So this will be side area. Then if I take roof area will be equal to 6 into 5. If I take floor, in that case floor area will be equal to same as a roof. So that will be again 6 into 5. Okay, so this way I will get the total area. Okay, so first we'll take only roof plus side area. So Q1 will account only for a roof and side area. So in this case I will put the values. So U value for this puff panel, it is given as 0.28. So 0.28 into side area. Now calculate this side area, whole this side area plus roof area. So that you have to calculate. So this will be 30, this will be 30, and this will be so calculate that side area. So this will be 24 into 248 plus this will be 40. So I think this will be 88. Okay, I think I am correct. 24, 48 plus 40, 48 plus 40, that will be 88. Okay. So 88 plus roof area, this will give you total as 88 plus 30, that will be 98, 108 and 118. So our area in this case will be 118. Here in Q1 I am considering only roof plus side. Okay. In this case T outside, so in this case T outside is given as 30 degrees Celsius. Okay, inside temperature is 1 degree Celsius into 24 divided by 1000. So calculate this area, this Q1. Calculate and tell me the answer. So what is the answer? Okay, I have one answer here. Others also please calculate for the confirmation. So there are two answers I am having. Uh, it is wrong. Okay, so what is the correct answer, Pradyum? Okay, others also please calculate so that there are two answers in front of me. Which one should I take? Again, I have three answers. So can anybody calculate other than these two people? Okay, so I think that answer I will take 229.95. Okay, so 229.95. So that unit will be kilowatt hour per day, right? So I have calculated only for roof and side. So Pradyumna, please see your calculator is working or not properly, right? So next I will calculate Q2. So Q2 will be heat transfer by the floor. In that case, the formula will remain say that is a UA delta T into 24 by 1000. So U will be 0.28 into area. So floor area here we have calculated as 30. So this will be 30 and into delta T. So floor temperature we are assume it as a 10 degree Celsius minus inside temperature 1 degree Celsius into 24 divided by 1000. So calculate this. So this will be the heat transferred by the floor to the cold room. Okay, others also please calculate. Magi, Prasad Magi, calculate the answer. Okay, I have three answers, 18.14, and Vaibhav has calculated as 1.81. So which one is correct? I think that 1.8 is correct. So I don't know which one is correct. Mage, calculate and tell.
That is 24 by 1000 or 24 by 100.
24 by 1000. Sorry, here it is 24 by 1000. So I think that answer will be 22.9. So why I'm dividing by 1000 to get kilo. Okay, so that answer will be watt hour. So in order to convert that into kilowatt hour, so this will be, I have to divide it by 1000. So that answer will be in kilowatt hour per day. So I think in that case that will be 22.9, and here that your answer will be 1.8, right? Okay, so your answer here, it will be 1.8 kilowatt hour per day. Okay, so thus we have calculated the transmission load. Transmission load means whatever heat carried inside by conduction and convection. Second load we have is a product load. So in our case, product is nothing but apple. So that the heat carried inside by apple, that we have to consider. Second will be product load. In that case, first we have to consider the sensible heat. So sensible heat Q3 will be equal to whatever mass we are putting inside per day into its specific heat into delta T. So T of fruit minus T in, uh, sorry, divided by 3600. So in this case, we are putting 4000 kg of apples per day into 3.65. Okay. Into T of fruit is 5 degrees Celsius minus inside temperature is 1 degree Celsius divided by 3600. Okay, so calculate this. So this will give again the value in kilowatt hour per day. So one answer I am having, that is 1.62. So please calculate properly because I am having some different values here with me. So 4000 kg per day into 3.65 is its specific heat into delta T divided by 3600. So yes, so that answer I'm having, which is given by Chandraprabha. So that is a 16.22 kilowatt hour per day. Okay. दिस इज अ सेन्सिबल हीट. सेन्सिबल हीट म्हणजे काय, ज्यावेळेस ऍपल बाहेरून येणारे ऍपल 5 डिग्री मध्ये आहेत, तो ज्यावेळेस तुमच्या फ्रीजमध्ये किंवा कोल्ड रूम मध्ये ठेवणार, ऑब्विसली बिकॉज ऑफ टेम्परेचर डिफरन्स इट विल इमिट सम हीट, सो दॅट विल बी सेन्सिबल हीट. देन नेक्स्ट इज रेस्पिरेशन. Okay, so whenever I'm putting this fruit inside the cold room, because of this natural decaying process, it will emit carbon dioxide, and also it will emit some energy. Okay, respiration is a oxidation process. Oxidation is a exothermic reaction. So in this case, Q4 will be equal to mass which can be hold inside the shell into its respiration rate divided by 3600. See here, in this case already I told you. So if I am having a cold room, I cannot make use of its 100% capacity. असं नाही की एक कोल्ड रूम मध्ये सगळीकडे ऍपलच ऍपल आहेत, दरवाजा उघडला की ऍपल बाहेर पडायला लागले, असं करून नाही चालत. ठीक आहे, त्या केसमध्ये काय करावं लागतं मला, आय हॅव टू फिल इट अप टू ओनली 50% occupancy. So 50% is occupancy. Then I have to keep some percentage for, let it be 10% for its exchange. तर 10% कधी मायनस होईल कधी प्लस होईल ते मला एक्सचेंज मध्ये धरावं लागतं. ह्या केसमध्ये त्यांनी काय केलं की त्यांनी हे जे मास आहे की शेल्फ मध्ये ऑन अन ऍव्हरेज किती केजी असेल, एका कोल्ड रूम मध्ये ऑन अन ऍव्हरेज किती केजी फ्रूट असतील, तर ते त्यांनी कॅल्क्युलेट केलंय. सो दॅट विल बी हिअर दे हॅव गिवन इट ॲज अ 20,000 kg. Okay, so that I will take here. So 20,000. See here, don't get confused. So 4,000 means what? 4,000 I am keeping inside the cold room per day. दररोज 4 टन माल मी त्यामध्ये टाकतोय. बट ऑन अन ऍव्हरेज त्याच्यामध्ये किती माल असणार आहे, ठीक आहे, दररोज मी 4 टन टाकतोय, त्यातला काही वेळेस काय होणार आहे, प्लस मध्ये जाणार आहे, मायनस मध्ये जाणार आहे. ऑन अन ऍव्हरेज ह्यांनी एक मास काढले की ते कोल्ड रूम मध्ये असेल. दॅट मास विल बी देअर ऑन अन ऍव्हरेज इनसाइड द कोल्ड रूम. So that is a 20,000 into respiration rate. In this case, it is given as 1.9. So 1.9 divided by 3600. So calculate this value. Okay, so I have three answers. I will take Sonali's answer, that is 10.55 kilowatt hour per day. Okay, so you can calculate that total product load. So QP is equal to Q3 plus Q4. So this will give total load. So I think that will be 0.776 and 1 and 1 2. So that will be 26.77 kilowatt hour per day. So that will be total product load. Next thing we have to calculate here, it is a internal load. Internal load means load due to lighting and people. So internal load. So in this case, see here internal load. First, I will go for lighting, right? So that will be Q5 is equal to total number of lamps. So number of lamps into time. So time when it is on into its wattage divided by 1000. So in this case, we have used the 3 lamps into it is, we have assumed that these lamps are on for 4 hours per day. 4 hours मध्ये ते एक क्युम्युलेटिव्ह आहे, म्हणजे कधी 10 मिनिटं चालू असतील, कधी 5 मिनिटं चालू असतील, तर क्युम्युलेटिव्ह मध्ये ते 4 hours per day चालू आहेत. Capacity for each bulb or the light tube, it is 100 watt we have taken and divided by 1000. So this is a very straightforward calculation. 3 into 4, that is 12, into this will be 0.1, so that will be 1.2 kilowatt hour per day. Okay, so this will be lighting load. The second will be people load. So Q6 is equal to number of people into their working time inside the cold room, okay, into heat per person. I'll write here heat per person divided by 1000. So in this case, there are two workers. Their working time we are assuming 4 hours per day, and heat release per person. So there is a whole table. It is given when we study in second section. In that case, I will show you. So different heat are released from person. So if I am sitting at rest, less heat will be released. If I am walking, more heat will be released. If I am running at a high speed, so highest heat will be released in that case. So all that depends on your metabolic rate. तुमचा जेवढा मेटाबॉलिक रेट जास्त होईल तेवढं तुमची शरीरातून जास्त हीट बाहेर टाकली जाईल. So that will be 2 into 4 into heat per person. In this case, it is given as 270 watts divided by 1000. So this, I think this is not straightforward. 4 into 2, that will be 8. 8 into 0.27. So that will be how much? 5, 8 to the 16. That will be 2.16. 21. 2.16. So that will be 2.16 kilowatt hour per day. Okay. 4 into 2, 8, and 8 into this will be 0.27. That will be 2.16 kilowatt hour per day. Okay. And you can calculate this internal load. So that it will be internal. Okay. So this will be equal to Q5 plus Q6. This will be equal to, again, this will be 3.36 kilowatt hour per day. Okay. This is about the internal load. Next thing is to calculate equipment load. So I am using some refrigeration system inside this cold room. In that case, whatever heat released by the motor of fan and defrosting, that we have to consider here, equipment load. So first I will consider the fan load. So in that case, let it be Q7. So in that case, fan rating, or this will be number of fans, then into time of their working, so how many hours per day they are working, into wattage, their wattage divided by 1000. So in this case, we have used 3 fans. They are working for 14 hours per day. Into their wattage is 200 watt. That motor is operating 200 watt divided by 1000. So can you calculate this? So this will be, so the net so the temperature and that into 2. 42 into 0.2, that will be 2.1. No, that will be 42 into 0.2, that will be 84, 8.4. So that would be 8.4 kilowatt hour per day. Okay. See, we can do this calculation manually also, uh, only if you know these tables. Okay. Then next thing is defrosting. डिफ्रोस्टिंग म्हणजे काय असतं, तर इव्हॅपोरेटर कॉइलवर जो आईस जमा झालेला असतो तो आपल्याला काढायचा असतो. तर या केसमध्ये आपण काय केलं की हिटर कॉइल एक वापरली. हिटर कॉइलची कॅपॅसिटी किती दिली त्यांनी, 1.2 किलोवॅट. असं आपण दिवसातून किती वेळा करणार आहे, 3 वेळा करणार आहे. ओके. So that we have to consider here. So defrosting, that will be Q8 is equal to, so power of that heating coil into its time, किती वेळ आपण वापरणार आहे डिफ्रोस्टिंग साठी, इंटू सायकल्स म्हणजे एका दिवसातून किती वेळा डिफ्रोस्टिंग करणार आहे, इंटू इट्स इफिशियन्सी. Okay. So see here, their power is given as 1.2 kilowatt. Okay. Into, it is used for 30 minutes. 30 minutes means we know that is a 0.5 hours into cycles 3. So 3 times per day that defrosting will take place. Their efficiency 30%. 30% means that will be 0.3. So calculate this. This will be 0.6 into 3 will be 1.8. 1.8 into 0.3, 1836, 1854. So that will be, I think, 5.4 or 0.54. So this will be zero point 0.6 into 3, 1.8 into zero point 0.3. 1854. So that will be 0.54. Okay, 0.54 kilowatt hour per day. Okay, this will be equipment load. So this also you can take cumulatively. So this will be equal to Q7 plus Q8 equal to, so 8.4 plus 0.54. So this will be 8.94 kilowatt hour per day. Okay. And the last load we have to consider here, it is the infiltration load. Infiltration load is an unwanted load. ज्यावेळेस तुम्ही दरवाजा उघडता बंद करता त्यावेळेस ते बाहेरचे एअर आत येते. So that will be infiltration and it will carry some load with it. So we have to consider that load also. So fifth is infiltration load. So let it be Q9, or I can straight away I can write it as a Q infiltration, QIF will be equal to volume changes. So number of volume changes okay, into that energy or the specific heat of air. Here we have to consider into delta T. So delta T will be T outside minus T inside divided by 3600 divided by 3600. So in this case, see here, this now number of volume changes, it is given as 5. But what about energy? So energy, they have calculated it as a specific heat into density of air. Okay. So if I calculate this, Cp we know 1005 into density is generally 1.2. This will give the value around 1.2 something. But in general here in this case, they have given this value as 2 kilojoule per degree Celsius. Okay, so this value they have given. So QIF will be equal to 5. 5 is the number of volume changes per day into energy, that is 2 into delta T. T outside is 30, inside is 1 divided by 1000. So calculate this and so this will be how much? 5 into 2, 10. 10 into 29 divided by 1000. Okay, so that will be, I think, 0.29. Okay, 0.29. But one thing is remaining here. So yes, here we have to multiply by volume. So number of volume changes into volume. So this will give you in meter cube. So here I forgot to multiply by the volume. See here our dimensions are 6 into 5 into 4. So here it will be 13 to 4, that will be 120 is the volume of the cold room. So I have to multiply by 120. So can anybody calculate and tell me what will be this infiltration load? Sorry, so here it is 3600. So here I have taken 3600. This will be 3600. I'm sorry for this mistake. That should be 3600. So whatever answer you have got, that is 34.8 is corrected. Okay, so one answer is there, 9.66. So others also please confirm your answers. Okay, so that answer I will take 9.66 kilowatt hour per day. So thus we have calculated all the loads acting on that cold room. Now I will calculate the sum of all this. Okay, so let us take a total. So I will go for total. So let us first calculate what will the sum of all these loads. So I will start with the transmission load. So here in this case, transmission load, it will be 22.9 plus 1.8. So that will be 22.9 plus 1.8 plus that this will be 26.77 plus this will be 3.36 plus this will be 8.94 plus this is a 9.66. So do this sum and tell me the answer for Q. Okay, I have one answer here. I will take that. That will be 73.43 kilowatt hour per day. So this is what I have done here, taken a simple sum of all these loads. But in actual, see in actual condition, when working conditions, we have to take one safety factor. तर हा concept तुम्ही machine design मध्ये ऐकला असेल, safety factor. Similar approach we have to follow in this case also. We have to take one safety factor. सेफ्टी फॅक्टर यासाठी घ्यायचं की कधी कधी काय होतं की आपण जे म्हणलं की 50% ऑक्युपन्सी आपण ठेवली, तर कधी कधी एखाद्याला वाटेल की जास्त लोड आपण द्यावा कोल्ड रूम मध्ये, म्हणजे 50% लोड पेक्षा तो 60% लोडला जाईल. कधी कधी जे फॅनची मोटर आहे ते एखाद्या जास्त हिट इमिट करू शकते. ओके, दोन वर्करच्या जागी तीन वर्कर आत बाहेर यूज करू शकतात. So we have to consider these factors which are not in our hands. So in that case, we have to assume one safety factor. So what I will do, I will assume a 20% safety factor. So assuming 20% safety factor. So in that case, you can calculate the Q total. So Q total will be 20% more of Q. Okay, so this I have calculated here. Pradyumna has calculated 73.44 and into 1.2. So 20% more, that means that will be 1.2. Okay, so 20% more, I hope you all know. So if it is X, if I take 20% of X, that will be 0.2. So 20% more means X plus 0.2X, that will be 1.2X. Okay, so this is 1X plus 0.2X. So 20% more means that will be 1.2. So calculate this and this will be your Q total. Okay, I have two answers. I will take Akshay's answer. So that is at 88.12 kilowatt hour per day. Okay, so this will be your Q total. Now what I will do, I have to calculate the refrigeration capacity. So refrigeration capacity, I can give it as a QL is equal to Q total There is a formula, Q total divided by number of working hours. So in this case, number of working hours are 14 hours. We have assumed that this cold room will work for only 14 hours. So divided by 14, calculate this. Okay, I have one answer. Others also please calculate and confirm your answers. Okay, so Rohit has calculated, Akshay has calculated. I will take Rohit's answer. So that is a 6.294. So I will take 6.3. This unit will be kilowatt. So can you convert this into tons? So calculate this in tons. Okay, so I have one answer 1.79, or I will take okay 1.79 tons. So that will be your total refrigeration capacity, right? So thus we have calculated the total refrigeration capacity. तर आपला ऑब्जेक्टिव्ह काय होतं, आपल्याला एक कोल्ड रूम डिझाईन करायची होती, त्यासाठी रेफ्रिजरेशन सिस्टीम डिझाईन करायची होती. त्या कोल्ड रूम मध्ये मी दररोज एक 4 टन ऍपल्स ठेवतोय, ठीक आहे. त्याची पर्सेंटेज ऑक्युपन्सी मी अजून केली 50%. त्यानुसार त्याच्यात ऑन अन ॲव्हरेज एक जर मी कधी पण ते दरवाजा उघडला होता तर ऑन अन ॲव्हरेज 20,000 किलो ऍपल त्यामध्ये असणार आहे, ठीक आहे. आउटसाइड टेम्परेचर आहे 30 डिग्री सेल्सिअस. कोल्ड रूम मध्ये टेम्परेचर मी मेंटेन करणार आहे 1 डिग्री सेल्सिअस. फ्लोअरचं टेम्परेचर आहे 10 डिग्री सेल्सिअस. ऍपल ज्यावेळेस मी आत घेऊन येतो, ऍपलचं टेम्परेचर एक प्री कुलिंग केल्यानंतर 5 डिग्री सेल्सिअस आहे. त्यानंतर मी तुम्हाला बरेचसे कॉन्स्टंट व्हॅल्यू दिल्या, जसं की पफ पॅनल आहे, इन्सुलेशन पॅनल, त्याचं मी तुम्हाला यू व्हॅल्यू दिली. देन वी हॅव कॅल्क्युलेट द एरिया. देन वी हॅव अज्युम द लोड बाय फॅनची जी मोटर आहे त्याचा लोड, त्यानंतर डिफ्रॉस्टिंग मध्ये लागणार लोड, त्यानंतर एक पर्सन एक वर्कर आत बाहेर केल्यानंतर त्याच्याद्वारे जी हीट तयार होते त्या हीटचा लोड, प्लस आत जे लाइटिंग असेल त्या लाइटिंगचा लोड, हे सगळे फॅक्टर आपण कन्सिडर करून शेवटी आपण हा लोड कॅल्क्युलेट केलाय. सो आवर टोटल लोड ऑन द सिस्टम इट इज 1.79. So this amount of heat I have to remove from the cold room. How I can remove from the cold room? With the help of a refrigeration system. तर हे असं कॅल्क्युलेशन चालतात, ठीक आहे. तर तुम्ही आता काय केलं, सक्सेसफुली ह्या कॅल्क्युलेटेड वन कोल्ड रूम. आणि जशी तुम्ही कोल्ड रूम कॅल्क्युलेट केले तर ह्यापेक्षा थोडी जास्त एक्स्ट्रा कॅल्क्युलेशन तुम्हाला लागतील इन केस ऑफ कोल्ड स्टोरेज. कोल्ड स्टोरेज मध्ये कसं असतं, मल्टी फ्लोर सिस्टीम असते, तर प्रत्येक फ्लोअरचं तुम्हाला काढत जावं लागतं. त्या सगळ्या फ्लोअरचं ऍड करून तुम्हाला एका सिस्टीमचं काढावं लागते. मग अख्ख्या त्या फ्लोअरला 4 फ्लोअरची बिल्डिंग असेल तर 4 फ्लोअरच्या कोल्ड स्टोरेजला किती कॅपॅसिटीची रेफ्रिजरेशन सिस्टीम लागेल हे तुम्ही इझिली कॅल्क्युलेट करू शकता. ओके, सो अप्रोच इज सेम. तुम्हाला सगळे हीट लोड काढायचे आहेत. हीट लोड काढल्यानंतर तुम्ही ते कन्वर्ट करा टन्स मध्ये. तुम्ही सांगू शकता की बाबा मला एवढ्या प्रकारची सिस्टीम लागेल. तर या केसमध्ये मी रफली सांगू शकतो की एक 2 टनचा मला रेफ्रिजरेशन सिस्टीम लागेल फॉर माय कोल्ड रूम. Okay, so same calculation what we have done manually I will do with the help of a software. So that Danfoss system, they provide a software for these calculations. I will show you. So this is a software which is called as a cool selector. You can also download it. It is a free software. Okay, so we'll go for a cold room. So see here, they are asking for this load, this dimension. So I will give the similar dimension. So 6 will be the length. Width is 5. Okay, height I have taken 4, so that I will put here. 4 meter is the height. Then I am giving the inner dimension, right? So temperature surrounding, I have taken it as a 30 degrees Celsius. 30 degree म्हणजे किती झालं? 303. So this will be 303 Kelvin. Temperature below floor, I have taken 10 degrees Celsius, so that will be 283. Relative humidity, they have taken 55%. Floor is insulated. So floor will not be insulated. There will be heat transfer from floor to cold room. Next, then goods. So in this case, I will search for apples. If apple is there, I will put apple, or straight away I will put a fruit. So apple is not there, so I will put a fruit. Quantity per day, that is a 4,000. Okay, no problem. Inlet temperature I will put here it as a 1 degree Celsius. That will be 274 Kelvin. Respiration heat load, they are not taken any, they are not given any window here. Okay, total mass room, that will be 20,000. Respiration heat load they should have given, but they are not given any window for that. Then room condition temperature. Okay, relative humidity, operating hours 14 hours, so I will take a 14 hours. Panels with polyurethane. Okay, no problem. So that will be 0.8, I will take 0.8 meter. So that will be 80 mm. Select. So after all that, this software has calculated the capacity. Okay, so I will show you what it has calculated here. Okay, so this is a cold room here. Door openings are regular. This is the dimension here. Temperature, humidity, fruits quantity. This all I have defined here. Defrost per day. So we have taken defrost as 3. 30 minutes will be its defrosting time. Okay. Lights is 240, but I think our case we have taken light as let me check the light. We have taken light it as 100 watt. So 100 into 3 lamps. So that will be 300. Fans 249 they have taken. Fans we have taken in our case it has 200 watts. So into 3 fans. Okay. So that will be 600 watts. People's 2 hours per day. I will take 4 hours per day. Other is miscellaneous. Then panel is given. Temperature surrounding, temperature below floor. Okay. So next I will put next. Then select the region. So they are asking the region. Why they are asking the region? Because the solar heat or solar load will vary from region to region. So in this case, I will take Asia. Then they have given our choice to select their components. So they have these commercial components. First is Optima Plus. Second is Optima Slim Pack. Third is Optima. So I will select this Optima Plus. Then they are asking for a refrigerant. See here they are asking for a refrigerant. So here I have choices R134A, then R404, R407. This is a zeotropic mixtures. Then R513, that is azeotropic. So okay, so I will select R134A. Then I will select next. Okay, so see here it has calculated the cooling capacity. So here cooling capacity they are calculated it as a 5336 watt, or we can say 5.33 watt. Okay, in our case, we have calculated the capacity. How much we have calculated here? We have calculated the capacity as 6.2 kilowatt. Here they have calculated 5.3 kilowatt, because in our case, we have taken 20% safety factor. Okay, here they are, I don't know if they have taken the safety factor, but they have calculated it as a 5.3 kilowatt. We have calculated it as a 6.2 kilowatt. So our value is set with more. So it is good that our value is more. Okay, जास्त असलेलं चांगलं आहे. ठीक आहे, कमी असल्या उलट सिस्टीम लोड येऊ शकतो. These are the given values. Then preferred thermostatic expansion wall material. So we have expansion wall. they are giving us choice whether we go for brass or stainless steel. Okay, then they are asking this connection type, soldering, whichever you want to put here. So that is related to the this installation operators, installation people, distance from condensing unit to the evaporator. So this distancing means that will the length of the copper tube or the whatever tube you are using, that will be length of that tube. Okay. Select. Now it will give me some report data. Okay, so all these components are there on my screen. It has given some specifications. So I will go for this report. So it will give me some report in the form of PDF. Okay, so this report is here in front of us. So we'll see what they have given in this case. So I can put my project name here also. So I will put it as a Apple cold room. Then comments created by, let us say by me, DDR. Okay, items to include in the report, select all. Okay, so we can get a PDF, all compress. Okay, okay, PDF standard. I'll put it on desktop. So let us say CC. So meanwhile, I will show you what they have given here. So we have created this. Okay, it is open now. So this is our project. This report I have generated. See here, we have used the refrigerant R134A. Then this is the system. So we have selected that Optima Plus system. So see here, evaporator pressure here it is given as 262 300 pascals. So this is roughly 2.62 bar. Okay, 2.62 is the suction pressure or evaporator pressure, which should be always greater than the atmospheric pressure. So it is greater than the atmospheric pressure. Then where is that condenser pressure? So they are not given condenser pressure here. Okay, so we'll see. Then superheat is 5.2 Kelvin is the superheating. Return gas temperature. Subcooling is 3 Kelvin. This means that there is a subcooling of refrigerant after condenser, and this superheat means there is a superheating of refrigerant after evaporation. Okay, so this is my model. We have selected Optima Plus, which is owned by Danfoss. Then this cooling capacity, they are calculated. So considering the other factors, they have calculated it as a 6041 watt. So that is roughly 6 kilowatt. So it is nearer to our values. We have calculated 6.2 kilowatts. Here they have calculated considering other values. So previously they have calculated something 5.3. So considering other factors also, they have calculated now it as a 6 kilowatt. रेफ्रिजरंट यूज केला या केसमध्ये R134A. Okay, so these are other parameters they have given in this case. Okay, so here they have given this condensing pressure. Condenserचं pressure या केसमध्ये किती दिले यांनी? So it is roughly equal to 10 bar. So we have 2.62 evaporator pressure and 10 bar as a condenser pressure. Okay, so this is a liquid line. This is a vapor line, dry suction line. Okay, this so here that cooling capacity they have calculated as a 6041. That means 6 kilowatt. We have calculated as 6.2 kilowatt. So not great difference is there between our calculations and the software calculation. Okay, so they are given this loads. So transmission load is 1.9 kilowatt. So in our case, let me go back to our calculations. So transmission load in our case, it was roughly 23 kilowatt hour per day. So that we have calculated in kilowatt hour per day. So if I divide it by 14, I know that this answer will be same. So they are calculated at 1.94 watt. Infiltration load is given. Then ice on evaporator. Lighting load they have calculated. People load they have calculated. Fan load is calculated. Defrosting load is calculated. And total they have calculated as a 5.33. Then they are calculated the infiltration. Okay. So this way this report is there. Okay, considering the infiltration, finally they have arrived at this value, that is a 6041 watt or 6 kilowatt. Okay. So this way we can make use of softwares also, or we can go for manual calculation. Choice is yours. So I hope that I have given enough emphasis on these tools, manual calculation as well as software calculations. I hope this will give some confidence in design and calculating this cold room or cold storages. Okay. And one thing, very important thing, I want to tell you that this was all beyond the syllabus. Whatever we studied in last two lectures, this was all together beyond the syllabus. This is design of cold room. This is not included in your syllabus. But I am glad that you all have paid very good attention. You all incorporated well with me. You did the calculations. Okay. So thank you all for that. So quickly I will take the attendance. Then we can stop. Okay. So intentionally, I didn't tell you that this is beyond syllabus, because if I tell you at the first, then there is a change in attitude. So, but I'm glad that you studied very well and you also calculated these things. Okay. Yes. Now it has taken attendance. Okay. So thank you for attending the lecture. In next lecture, we probably start the remaining chapters of our syllabus. I'm trying to go very slow in this process.